Welcome to the Course One podcast. In this podcast, we explore the emerging open financial system. We dive into scalability, interoperability, proof-of-stake, blockchains, and many other parts of this coming financial singularity. Tune in every Monday to dive deep into these cutting-edge projects and protocols with Course One team members and guests.
Hi, and welcome to the Chorus One podcast. In this episode, we're joined by Soravis Srinawakoon, the CEO of Band Protocol. Welcome to the podcast, Soravis.
Hi, guys. Hey, thanks for having me here. That was actually the best pronunciation I ever heard. So I got it right.
Sawadika. So, why don't we start with a bit of like a standard question that we always ask our guests? How did you end up in this crypto space and started to found Band Protocol?
Sure. So it was probably back around 2010 when I was studying computer science for my undergrad at Stanford. That's when I actually get to study cryptography. That's how I got into the whole blockchain and Bitcoin around 2013. MIT did a free airdrop back then, and my friends also got it. So we started talking about this whole new internet money, because back then nobody really talked about it, right? We sort of got into that around 2013 along with my co-founders. And then we started a application, which is essentially a mobile game that give free Bitcoin to people. And it was way back then, right? Around 2013, 2015, where nobody was really doing that. And then we sold that business and then turned full time into Band Protocol around 2017. Because that's when things were picking up, and we realized that we really want to be full time in cryptos and we want to contribute more to the industry. So I guess that's a quick background of how we got into it, and then per Band, I guess the background on Band Protocol was that we sort of, after the crypto faucet, right, we start working around with smart contract, working around with this betting applications or sort of application on Ethereum, and then quickly realized it was really difficult to build NED apps without connecting to real world data, right? And that sort of lead to this Oracle problems, and that's how we lead to us pivoting to full time into Band Protocol.
Okay, I guess that's a good segue into what Band is about. So you already mentioned this Oracle problem. Maybe you can explain for listeners in your words, what is this Oracle problem?
Right. So, if you are a developer, right, and you write smart contract on a blockchain code, right, to automate something. The problem is all these smart contracts have no way to access data outside of blockchain. The only data that they can access is actually information inside or internal to the blockchain itself, right? And that means this make their use case really limited, right, and make them really difficult to build NED apps for real use cases. So, for example, if you want to build Uber, for example, and you don't have Google Map, and you have to build all this location data from ground up, it's going to be really difficult, right? If you have any sort of application and you want identity data like log in by Facebook, that's also impossible, right? So these things are essentially all the data outside of blockchain, cannot be easily fed into blockchain itself. And so this is what Oracle is, right? An Oracle service is essentially a service that connects real world data, the external data, into blockchain application so that the app can utilize this. I guess some more relevant examples that a lot of us see are in DeFi, where all of them, virtually almost all of them, require external price feed, right, to operate right now.
Yeah, I think we will get a bit more into the specifics about DeFi and oracles. I think that's actually right now the biggest thing we're seeing where oracles are used at the moment. But maybe before we do this, we can get a bit into like Band's solution and how the protocol works and how maybe a transaction or a user flow happens. How is someone interacting with Band? How does that look?
Sure. So, if you think about this, right, this whole Oracle problems, it means, the data is outside of blockchain. So you need someone to actually report that data into the blockchain itself, right? That is something you cannot avoid. So in order to make sure that is fully decentralized, so that you don't rely on one person reporting that data, Because if that person is, incorrect for some reason, then the whole application fail, right? As you've seen in, many of these DeFi examples, we will, I'm sure we'll go into detail in a bit. But essentially, you need someone to report the data. And what Band Protocol does is essentially created a delegated proof of stake style system where you have a lot of the validators, the stakers, people who stake Band tokens, act as we call it data validators, right? Or you would call it block producer for other blockchain. These entities, so including Chorus One, essentially stake tokens, the Band token as a collateral. And then they have two jobs. One is to validate the blockchain transaction, similar to other blockchain. And then the second one is essentially to report the data or run the so-called Oracle script, which essentially will fetch the data from specified sources, aggregate the data, and report the data into the blockchain itself. Okay? So that's essentially the first party in our ecosystem, this so-called data validators. Now, there are two more, parties involved in our ecosystem. On one end, you have the data users. So these data users are essentially the apps, right? Decentralized application, including DeFi, including gambling, gaming applications, or even enterprises who essentially need data outside of the blockchain, right? These data users essentially make a request to the data validators and say, hey, I want, for example, I want Bitcoin per USD, right? The Bitcoin price in US dollars every 5 minutes, right? And I want it from, let's say, 20 reporters. Submit that to the data validators. Data validators essentially run those scripts, right? Retrieve the data, give back the answers in exchange from the fee, right? In running all of this, right? So that's the second party, the data users. And then the third parties are the data sources. And these data sources are essentially, website or, entities that actually have the information. So in our example, that might be Binance, that might be CoinGecko, CoinMarketCap, and other financial data feeder, right? And these are, if we want to go into more detail, there's a lot of, segmentation between this as well. So for example, some of them, provide public API, essentially public information. So that's really easy for our validators to retrieve the information. Then you have the private API where essentially you have to pay money to retrieve the data. Those are some of the problems that we are digging deeper into and essentially figure out how to bring those data into blockchain easily. Right? And so, yeah, I mean that's in a high level how we sort of approach the problems. And I guess the question is, how are we sort of different to other blockchain solutions as well, or other Oracle solutions? And I wouldn't say we're better. I would say we are different along 2 or 3 dimensions. Okay? One is definitely the economic incentive. So right now, all of our validators will need to stake tokens as a collateral. This is to ensure that they will, stay 100% uptime. They will not cheat because there will be a big cost associated with that, right? And in exchange for that, obviously they earn the QE fee as well as the inflation from the system. So that's something unique about us for the first one. The second one is what we call programmabilities, which mean that any of the apps that want to query the data can write a really customized script, really flexible script to ask for data that they want, right? They can specify how many sources they want. They can specify how they want to aggregate the data and get back the data. So this allows a lot more type of application to use our Oracle easily without having to work closely with the team because it's almost like a generic smart contract platform, right? So that's really easy for developers to actually write their own Oracle script. And then the third bit is around data consumption model. And this data consumption model means, for existing Oracle solutions, so for example, MakerDAO, it required all this data Oracle or data providers to submit the answers in advance, right? They need to submit the answer in advance, let's say every 10 minutes. And so there might be a problem if the data is delayed in time of congested network that we have seen, right? Whereas for us, we can actually use our Oracle within one transaction, or we call batch messages. This means, within a single transaction, the process to use the data, to request the data, are batched into one. And so there is almost no delay in terms of data usages, which means that it's really difficult to actually use outdated information and game the system.
So can you just clarify that point then? You're saying, so there's a script that runs. So when I request data, that transaction will trigger something on the validator node that will run the script, get the data, bring it back, and send it back. Is that what you mean?
That's right. It means that, for the script, right? It means instead of a fixed script, anyone can actually write a custom request to our data validators and specify how many sources that they want to get the data from.
Okay, but is there not some process for consensus then on the data? Does the validators not have to agree that data is valid, or is there not some kind of majority voting on the data that's being returned, or some?
Right. So that is the aggregating method that I mentioned in terms of how do we get into consensus, right? For example, with the apps, right? They may say, okay, data validators, why don't you get my Bitcoin price from these 10 sources? And how I want to aggregate it is essentially take the median of that data.
I understand that piece. So you can go to CoinMarketCap and Binance and CoinGecko, whenever you get all the data, you aggregate that. But that response needs to be verified by the other validators now, because the validator that gets that data could manipulate that data before it sends it back to me, right?
Right. Understood. So that is not enforceable by the protocol itself. What is enforceable is at the, smart contract or the user level, right? For example, I say I want the data from 10 validators, right? I want the data from 10 validators. Now, from these 10 validators, I would write my own data check or data integrity check to see what is the difference between all these 10 data points that I got back, right? Because if you think about this sort of data, for example, Bitcoin price, right? There is no actual, truth or actual answers, right? Because some might say it's 7,000.1, some may say it's 7,000.3, right? As long as it's not obviously, 6,000 versus 7,000, then that would be a big difference, right? And these, check are actually enforced at the DApp level, not at the protocol level. What the protocol level ensure is that the data validators will have to, run the script according to whatever they ask to retrieve, and then sign those data and sign the result back, right? And
there's a bonded curve piece to this as well. Can you maybe dig into how that works? Like, is there incentives here for people to create new data feeds?
Right. So actually, that's a great question. That is actually on the original model that we launched on Ethereum, right? In our original model, we were, sort of, prioritizing the factor of decentralization, the securities, by having this bonding curve. Essentially, we will issue new tokens for every new data set that come around, right? The problem is that, after we launched for the past around 6 months and taken a lot of user feedback, it add a lot of frictions to the users, right? To the app users, as well as the token holders in terms of staking, in terms of actually requesting the data. And that's why, in the upcoming band chain that we're going to be launching soon, we are actually getting rid of that. So we will not have any bonding curve in the future version of band chain, and we will only have band token as the only sole token that people use to stake. And like I said, because of this new Oracle script, it will allow anyone to write a custom script to get any type of data that they want.
So can you then just talk a bit more then about how do the incentives work, right? So validators are staking, they're presumably, so they're getting fees every time they report data, is that correct?
That's right. There are two main components to the fee itself as of data validators. One is you earn part of the inflation, right? As you stake the token and you earn the inflation proportionately, right? And then the second part is the query fee itself, right? And the query fee, you can think of it almost as when you run Ethereum, right? As a mining pool on Ethereum, you actually get transaction fee that is proportionate to the actual code that you actually run on Ethereum. Right. So with that analogy, it's the same in band chain, where if there are the end users are the apps that request the data, the more customized, the more data that they want, then the higher the query fee will be. Right. It will be proportionate to that. And that is something that our validators will earn in addition to the inflation itself.
Okay, sure. And you mentioned then there might be private data. So the data sources themselves will presumably need to be incentivized in the future. Is that a problem to be solved in the future then? Or have you thought about like how would the protocol deal with rewards for the people who provide data?
Right. So we're actually working on that at the moment privately for the next iteration. And that means, yes, the data source will need to be paid, right? Just like similar to how we usually pay for API fee, access fee, right? What we are currently researching is how to actually implement some sort of stable coin within our system, where the stable coin essentially then will be used to make the payment directly to the API provider or the data source. And this will be done with the validator as well. So that's something we're actually researching at the moment.
Okay, great. So you've built this on top of Cosmos SDK. Can you talk a little bit about how that experience was and maybe how you see this fitting into the wider Cosmos ecosystem and how it plays out with IBC and other Cosmos initiatives? And maybe then talk a little bit about Game of Zones and how you're involved with that.
Mm-hmm. Yep. So I think two reasons why we choose to migrate everything to Cosmos, right? One is as you mentioned with the IBC, then essentially we would be able to connect to smart contract blockchains as well as other blockchain that run on top of Cosmos, like Binance Chain, Terra in Korea, and other blockchain as well, right? So that's something that we always have in mind in the first place, that we want to be able to connect and provide this Oracle service across multiple smart contract platforms. And the second bit is on the scalability part, right? Initially, we run on Ethereum, similar to other Oracle solutions. The problem with that is, in time of congestion, like what we have seen before, there will be problems when the data validators actually report the data, and that is actually pretty bad for application that require much more scaling capacities, right? For example, gambling, gaming, that required almost every second request to, let's say, random number generators, for example, right? So Ethereum was not suitable for that. And that's why we want to move away from that to Cosmos to essentially speed up our blockchain. And now every request can be processed within just a few seconds. And it can be fed across multiple blockchain within one transaction. And that will be able to allow us to actually answer a lot of these requests from our client that require more scalabilities, right? So that's, I guess, the part why we are, how we envision we fit into the Cosmos ecosystem is that we'll be able to feed all these data requests or provide this Oracle service to all the application run on top of Cosmos. So that's how we think about it in terms of the upcoming Game of Zones and all that. Obviously, we are working really closely with the Cosmos team on the IBC bridge on how to bring data safely and securely across blockchain. Right now, it's still in an early phase, but yeah, we are collaborating on that at the moment.
And are you planning to get involved in Game of Zones, and how do you see your role there? And also maybe talk about that upcoming hackathon that you're doing with the Cosmos guys.
Right. In terms of Game of Zone itself, I think we are planning to run our own zone as well. But honestly, I don't think we have a I guess a solid plan at the moment for that event. But for the hackathon, which is what we put a lot of energy on, is essentially provide an Oracle service, right, with an IBC plugin, so that developers can already build the apps utilizing Cosmos IBC as well as Band Protocol Oracle. Next, basically toward the end of this month. And the virtual hackathon will be run for 3 weeks. We'll figure out essentially what we want to do is onboarding more developers into our ecosystem, creating more applications and use cases. So yeah, really excited to see that. We have seen some promising projects that already submit some of the GitHub and all that. So looking forward to that.
Okay, really cool. Yeah, sure. So I guess we already alluded to it a lot in the beginning, that oracles are one of the main things that are needed in this decentralized finance applications. So I think maybe it makes sense for us to go a bit more into this field, because also that is where right now we're seeing like most activity on Ethereum and elsewhere for oracles and usage. So maybe just for some context for our listeners, can you maybe go into why many of these DeFi applications rely on price fees and how that works?
Yep, definitely. DeFi applications are, I guess, I'll break it. I will break them down into a couple of categories, right? One is stable coin. So, for example, like MakerDAO, right? Then the second one is loan, right? So crypto backed loans such as Compound, B0. I guess B0 is more like margin trading, but I'll probably group them into the similar categories, right? And then the third category is derivative. And this derivative is essentially projects that build token that mirror some other asset. So for example, the actual project called Synthetics, right? Which is essentially creating a synthetic tokens, right? Now, all these three verticals actually require Oracle in order to operate. So let's start with the first one, stablecoin. The way all the decentralized stablecoin work at the moment is essentially you need to put some tokens or some asset, right? Crypto asset as a collateral, right? In order to borrow some money. So this is like just decentralized pawn shop is a better word, right? For that smart contract to work, they need to know what is the value of that collateral. So essentially, what is the price of Ethereum at that moment, right? MakerDAO require that to operate. And this is actually quite similar to crypto-backed lending, where you put up crypto tokens as a collateral to borrow other asset class, right? To borrow other tokens. So you may be able to put in, let's say, BAN tokens in order to borrow Bitcoin or in order to borrow Ethereum, right? In order for that to work and to ensure that the system is fully collateralized, the smart contract need to know the value of the asset in a precise number in a really accurate time, right? Otherwise, because this token fluctuate really quickly, if the token price drop below the threshold that they have, then they will need to figure out the way to liquidate or actually sell the asset in order to make sure their system is still fully collateralized. Okay, and that's why they need Oracle in order to determine the value of those assets under their system, right? And that's actually really critical, because if the number is incorrect, people can actually game the system and the whole system can actually collapse. And this is why DeFi is so important, in DeFi, right? So that's the first and the second use case. The third bit is on derivative. And this one is essentially if you want to create a token that mirrors some asset outside of blockchain, like let's say stock, Apple stock, or commodities like gold, you would need to know what is the actual price of those commodities, right? And asset. And again, you will require Oracle service to feed that information in I guess, most real time as much as possible, in order to prevent people from front running and arbitraging, right? And that's why, again, Oracle and DeFi are almost like are almost coupled together, and it's really I would even dare to say is the most important function of DeFi right now, because if Oracle is incorrect, the whole DeFi is incorrect as well, right? Because the nature of smart contract is deterministic. That means whatever input you put, it will give you a deterministic output, right? And so if the input, which is the price, is wrong, then the output will be wrong as well, right? And that defeats the whole purpose of decentralized, finance in the first place.
Okay, thanks. That was a very good explanation. I think, we can talk a bit more about like some practical issues you saw. I think you also alluded to earlier that there has been this problem with congestion, and that maybe you cannot get the right price in because there's like limited scalability on Ethereum, and that's the reason that you moved to Cosmos, or why you moved to Cosmos. Now, recently, this situation happened basically on Ethereum, right? We had this big crash, Black Thursday called it. It's like a few weeks ago when we record this, where basically like all the collateral value of crypto assets that back these stable coins or anything else that rely on this collateralization ratio dropped significantly and led to a lot of liquidations and updates and reached Ethereum reached kind of the peaks of scalability and a lot of high gas prices. So maybe again, can you quickly talk about what were the problems in this scenario? Why how this extreme volatility impacts this whole DeFi Oracle cycle, and maybe then go into a bit how you think Band can help solve such issues or tackle these problems.
Right. Okay. I'll try to make it as simple as possible. So on a high level, right? Let's go back a bit in terms of how MakerDAO works, right? And this whole decentralized stablecoin. What Maker does is essentially rely on a couple of data providers, right, on Ethereum's who submit price data, say every 10 minutes to update the price. Right, and these data providers are essentially some other projects, like Set Protocol, for example, as one of the data providers. Right, so they have a couple of these that they make contract with, right, in order to submit the price. Right, and Maker essentially use this price to determine the loan to value ratio that we just talked about, right, and enforce liquidation. Now, when we talk about liquidation, it's actually not simple, right, because as a smart contract, how do you actually sell an asset? How do you actually sell Ethereum's tokens? Okay, one way to do that is actually sell on the decentralized exchange. The problem with that is obviously the slippage is really high, right? If you have to sell, let's say $5 million worth of Ethereums on the decentralized exchange within one transaction, that will cause a lot of a huge drop in price, and actually that might lead to underprice again, right? So that's the problems. Now, for MakerDAO, what it does is through this liquidation process, MakerDAO actually doesn't liquidate the Ethereum token itself. They actually auction the token out, right? So let's say if they determine that right now Ethereum is worth $100, they will sell these tokens at a 3% discount, right? So let's say Ethereum will sell at, MakerDAO will sell these Ethereums at 97 cents, right? $97, right? So then, other people who actually watch the MakerDAO system will say, okay, I will bid this and I'll buy the Ethereum from MakerDAO because I will arbitrage and actually earn that spread, the 3% spread, right? Because nobody will actually buy from goodwill, right? They will buy in order to profit from that, right? And that's why it's really important that the price of Ethereum is reported accurately. Now, what happened on that Thursday, or the Black Thursday, right, was that Ethereum was really congested. All these data providers cannot submit the data point into the system, so then they cannot update the system, right? So what happened was Ethereum price remained at certain price. I can't remember the exact number, probably let's say $160, right? So the price was $160, but the actual price itself was actually $120, right? Maker smart contracts say, okay, they take the $160 reported price, calculate the 3% discount, and then auction it off at, let's say, $150, right? Again, make up number just for illustrative purpose, right? So Maker say, I want to sell this at $150. Obviously, nobody will buy that because the actual price is $120, right? But the Maker system thought it was $160, wanting to sell at $150. Nobody want to buy that, right? And because of this auction bidding system, nobody bid on that. So somebody was smart enough to say, okay, I'm going to bid $0 for that, for those Ethereums. So they actually win with $0 because nobody else was bidding, and then earn free Ethereums, right? Almost about $4 to $5 million worth, right? So that sort of lead to MakerDAO system being under collateralized by about $4 to $5 million. And they were scrambling to actually print more Maker or try to cover the losses, right? And that is a big problem. And this is not just Maker. If you look at Synthetics and you look at Chainlink, Synthetic rely on Chainlink at the moment, for example. Chainlink also wasn't able to update price for a couple of hours as well. And that was a big issue as well, because if you're not able to update price in real time, then it's because of the network congestion, then the whole app cannot run accurately, right? Again, this is not a problem pertaining to Chainlink or pertaining to MakerDAO. It's just the fact that network was congested, right? So not to blame these two projects or anyone, but just saying that because network was congested, that leads to these whole problems of data not being able to update it accurately, right? So that was a long-winded answer to how I guess how Maker and wasn't able to liquidate the tokens. Now, how does BAN I guess try to tackle these problems, right? Essentially, this is one of the reasons why we migrate to Cosmos as well, because all of our computation, let's say data requests, data aggregating, and reporting the data, most of those happen on Cosmos, right? Happen on our BAN chain. So what that means is obviously it wouldn't be problematic with it doesn't interfere with this Ethereum congesting network. So it would be able to run it by itself and would still be able to answer the data, let's say within 3 to 4 seconds, right? The only thing that will interface with Ethereum was when we actually report the data back. So when we report the final answer along with the signatures and all this verification to Ethereum, that happened with one transaction, right? So with that one transaction, obviously we needed to go through in order to avoid the same problems. So then we will need to increase the high gas cost in order to essentially get it through, right? This is fundamentally different to other, I guess, solution on Ethereum, because if you need AV transaction or AV computation, such as getting the data, retrieving the data, computing the answer, reporting the answer, that's a lot of, I guess, transaction that need to be processed. And then you wouldn't be able to go through, even if I guess you can solve the same thing by increasing the gas fee, but the problem is that will actually cost you a lot of money, which is not really practical, right, in real business. Whereas for this, we actually only need to increase for only one transaction, which is I guess the most minimal or the least amount of number that you need to do, anyways, right? So that's how we intend to solve the problem of congested. And the second part is because we essentially take all the computation off-chain from Ethereum. When we report the answer, we can report the time that we actually get the data, right? So then on Ethereum itself, they can actually check whether the time of report that different to the time that they process the data. So if the time is, let's say, lagged by almost 5 minutes, then revert the transaction. That will not happen, right? So that will prevent problem from data being outdated in time of congestion. Whereas right now, the model that most smart contracts are implemented, they cannot do that because what they do is they actually just read the answer that are already on the blockchain, in which the data reporter just go update it. Right.
So if you revert the transaction or this doesn't happen, what would Maker then do? If, like I say, then there's no price from the Oracle for this period?
So that means so that means I guess. Yeah. So the problem is with that reward transaction, it will not prevent people, I guess, in the Maker scenarios, it will not prevent them from being under collateralized because essentially what happened is, what I mean is if that happened in Maker, right, they will not be able to sell the tokens anyways. They will not be able to sell Ethereum because the transaction will reward, right? Whereas in the current scenarios, they are able to sell the token, but at $0 because somebody was gaming that system. Right.
Mm-hmm. Okay.
So then the actual total loss will be much less than what they actually incur, right? But in the likelihood scenarios, what will happen is because they're not able to, again, they will not be able to reward if the data is not being able to be pushed within a small time frame. Then all the transactions will be rewarded. Nobody will be able to auction those Ethereums at an incorrect price, and then nothing will happen.
So you mean then you just wouldn't allow this liquidation to happen at this?
That's right.
Okay.
That's right. Because why would you allow liquidation to happen when the price is not updated, right?
Okay.
That would be the big problems. Right?
It's like a circuit breaker.
That's right. It's almost like a circuit breaker, right? But again, in our scenarios, hopefully, because we only require only one transaction, we can actually jack up the gas fee to ensure that our data actually go through. Right?
Okay. Yeah. Thank you so much. This were very helpful, and yeah, let's see how this all goes. Definitely interesting to see like stuff happening in a live network, right? You can theorize about a lot of stuff, but now.
For sure.
I guess.
It's really
It's
exciting,
nice.
right? Because I mean, you see all this happening in a span of 1 month. You almost see all top project being hacked by Oracle, right? You have B0X that use Kyber on-chain price. You have Synthetic using Chainlink incorrect, gold data. You have MegaDAO with congested network. Almost everything happened, right? Obviously, nothing happened to Compound because they use a centralized price feed at the moment. So.
All right. Yeah, I guess that's another trade-off you can make. Yeah.
That's a trade-off you can make, right? Yeah, unless somebody break into their office, then then they can actually hack that centralized Oracle feed.
So just to wrap up, I guess we could talk about the go-to-market strategy for a bit. You guys have been extremely busy signing up lots of partners. So do you want to talk a bit about kind of the highlights of that, of which partners you signed up, and then maybe talk about the future? And even like the long-term future of this, like how do you see this feeding into, say, enterprise adoption and things like that in the long term?
For sure. So as you said, we've been really busy integrating with other apps. I think a lot of the recent incident really highlight the importance of Oracle, and more importantly, the importance of not relying on one solution. Because if you're relying on one solution, then you are putting full trust of your system into that one entities, right? And that's actually a scary thing to do. If you're a business, you don't want to rely on one solution, right? Just like business relying on supply chain from China, and then they got a problem with this COVID thing, and things are not doing great, right? And so people are looking to diversify their solutions. So that's a great thing. What our go-to-market right now are involving, I guess, three things mainly. One is integrating with the apps, right? So a lot of DeFi, we are continuing to work with them. As you have seen with B0X, for example, we continue to figure out how to integrate with them, as well as other solutions to make it as bulletproof as much as possible, right? And beyond DeFi, actually, which we haven't really touched much, there are actually a lot of use cases coming up, including gambling, insurances, gaming, that are actually moving from, just testing mode into full production mode. So, those are coming up real soon. And that's something that we are excited about as well. So that's the first part where we are integrating with a lot of the apps, growing our integration team. The second bit is, integrating with other blockchain, right? Again, we want to be a cross-chain Oracle service that able to provide to all the smart contract platforms. So we are continue to work with a lot of other blockchain like Phantoms, like Cosmos, Polkadot, other ecosystem to bring our Oracle service to them. Because regardless of whatever smart contract you choose, smart contract platform that you choose, you will require an Oracle service anyways, right? That's inevitable. So that's something that we want to push on at the moment. And then the third bit is on the enterprise use cases. So as you mentioned, we want to push on this private enterprise development that are leveraging smart contract. The problem is, again, before they were trying to use smart contract, but it was really limited in use case, right? They're not able to bring data in and out of blockchain easily. So this is sort of tied into our visions and what we want to see in game as well. Because in the long-term planning, we envision that smart contract will be used quite extensively with a lot of enterprises, with other type of the apps beyond finance, right? And so, with that proliferation, you would need an Oracle service to be an interface or the bridge between real world and blockchain, right? Think of it as input-output of the blockchain world, right? And that involve working with enterprises, including supply chain work, including internet companies that have a lot of data that they want to be fed into blockchain to be used there. A lot of those use cases, although we can't discuss much, but we're having a team that really go after this and really work a lot closely with enterprises right now to bring that to life, right? And that's a long-term vision. So obviously, there's a lot of technical difficulties, a lot of research problems that we are going through right now. But hopefully, in the next couple of years, when smart contract really take off into mass adoption, then Oracle will be there as well. So we will be coupled there and hopefully provide that solution for all the enterprises that want to use that.
Okay, very good. Sounds very exciting. And maybe just one last thing then, just next steps for you guys. When's the network going live? You've got the hackathon coming up. What other things are coming up in the next quarter?
Yeah, so this quarter will be exciting. Definitely, we're going to be launching BandChain within this quarter. We are in almost a final testing period where we are testing with all of our validators. We are stress testing the network. All these edge cases, as well as finding new use cases with the hackathon, right? So this quarter, definitely going to be launching that in terms of the next band chain. We're going to be ramping up our integration. So you'll hear a lot more from us as well in terms of new use cases, more DeFi project using us. So that's obviously going pretty well. And the third bit is community outreach. So we're going to be, focusing a lot more international effort and global effort, going after, not just Asia, but also US and Europe market as well, in order to gain more, mind share in those markets by doing more hackathons, more events. Although, obviously with the virus situation right now, hasn't been easy. But we'll push through and then organize some more virtual hackathon podcasts and all of this.
Excellent. That's great.
Awesome. Yeah.
Awesome. Yeah. So really excited. Thank you as well for joining us as a leading validators, as well as this podcast. I think it was really helpful.
Yeah. Thank you very much. Really great to talk to you. And Felix, do you want to just wrap up there?
Yeah. Thank you so much for coming on, Soravis. It was really nice. And yeah, we'll link to all the stuff that Soravis mentioned in the show notes, and hopefully, we'll see many people on Band and lots of projects, integrations, and transactions happening. So see you.
Awesome. Thank you as well. Cheers, guys.
Thank you for listening to the Chorus One podcast. Visit chorus.one for more information about our work. Don't forget to subscribe to the podcast to stay tuned on new episodes airing every Monday.